Okay.
I was in Egypt last year, looking at the hieroglyphs and the wall paintings, and something suddenly struck me. There was a slave pulling a large stone, and from his hat, he had a strange design coming out with a wire wrapped around it, and it gave me an idea of whether the ancient Egyptians knew something that we didn't. So I've constructed something to try and replicate what they were trying to say to us. So I was quite keen to do some background research on what I'd seen over in Egypt, I discovered that what it was a Babylonian scepter, and I've recreated it here. We'll call this the RBS coil. What we have in this setup is a bridge rectifier here with the AC going in at one point. It then continues to ground on another point, and then we've got a lead going into our multimeter, and we'll see if it gave in the energy to pull the stone. Okay, so what I'll turn on the multimeter and we'll see what we're getting out of it. Okay, so we're pulling around 2.1 volts on DC. I've got an idea that he must have been drawing a lot of energy from the pyramids around that area, because I don't think 2 volts is going to be strong enough to pull a stone like he was. So I find that quite fascinating, and it just oh dear. What are you doing, man? Oh, Ash, now they know everything.
Okay, so we've been caught red-handed with our BS coil, unfortunately. So what's under the sheet here is a wire that's plugged into the mains. And what we've got here is a very terrible transformer, an air core transformer, between the electromagnetic field that's induced by the AC in the wire and this BS coil. So of course this coupling works without the BS coil because the coil is just BS. So we're kind of joking around with the BS coil and so on, but part of it isn't BS. We really did get power transfer between the AC field generated by this and our antenna here. And it was rectified, and the value on the multimeter of 2.2 volts was correct. That really was being transferred. And it's not just an empty voltage, there's current there as well. I connected up a capacitor to this, and you can charge up a capacitor enough, and then you can put an LED over it, you can see the LED flash, and you put a bigger capacitor, you can see the LED light on for a longer amount of time. So even with such a terrible coupling between the antenna and the transmitter, you can receive power. You can wirelessly transmit power. And this happens all the time. It's not really that surprising. When you have your mobile phone and you receive a voice from someone on the other side of the world, that last leg of it from the base station to you is wireless power transfer. It just so happens that on top of your power transfer, you're encoding a signal, which is your voice. So it is actually quite interesting. And you might think that power is completely useless. It's not, actually. I mean, you could use that, for example, to trickle charge a smoke detector, or you could save up the power over a month or so and use it for some wireless sensor application that only needed to report back once a month. Then you wouldn't need to have an inbuilt battery that runs out. You could just put it near a AC wire somewhere in your building. So you could actually use that wireless power transfer for something practical. Now, we've been experimenting with wireless, receiving RF energy. You know, the stray RF energy that's everywhere from all the GSM transmitters and all the other sources of RF that just flood our environment constantly. And we managed to confuse ourselves a little bit. And in this next segment, we'll show something which was actually quite funny when we realized what we'd done, but to just illustrates how careful you have to be, how much you have to kind of bend over backwards to not confuse yourself, so that what you're really seeing is what you think you're seeing.
One of the things we wanted to know was whether the amount of RF we're detecting with these aerials is dependent on how high the aerials are up in the air. So I'll pull this up to the rafters, and if you keep your eyes on the meter, you'll be able to see the difference in the reading.
got to say the secret password to Rob. The purple pussy tulips silently through the tulip factory. Okay, as you can see, the power that we thought we were receiving from up in the rafters is actually coming from the lights. Alright, so when we did this experiment a couple of days ago, we expected to see the voltage increase as we raised the antenna, or we had hopes that we might see that. And because we were looking for that, we saw that correlation. And you saw it yourself, that the voltage increased as we increased the height of the antenna. So we thought that that's what we saw. It was only because of our keen scientific minds that we eventually noticed that actually it was the coupling between the lights and the antenna. But that was a really interesting, kind of sneaky little joke on the part of the universe to have it set up like that. And it illustrates that you've got to be very careful when you're designing scientific experiments.
So this whole video really is about experimental method. That sometimes when you're looking for something, sure enough you find it. And you have to ask yourself the question, is it what you've really found? Now, having looked at that idea of things, then it is without a doubt that the RF energy is there. It can be collected. The fact that we're collecting it from the lights doesn't really mean anything. Those lights are emitting energy that we can collect. Now that energy is being emitted to the whole space all of the time. If we don't collect it, it's lost. It's a bit like a water wheel. If you have a river flowing downhill with a certain speed, and you put a wheel in it to collect some of that energy, then the water up here will stay the same speed. But the water down here gets slower. So if we think about our light emitting its RF happily, or any other RF emitter, then if we put a shield in here, then we'll get that RF energy that we can draw out to do some work. This, the emitter, won't see that. The emitter won't put out more energy, just like the water won't get faster. The energy put out is put out at a constant rate that is then lost. When you collect it, what happens to the back bit here is you create a shadow. All of that energy, if you do it really efficiently, will be collected by your plate and you can use it. Nothing will come past here. So that's what's happening. All of this, without your shield in the way, without your collector in the way, is just lost energy. So if you don't collect it, you're not using it. Now there's an awful lot of RF kicking out there. This thing sort of began in about 1919 with the first radio transmissions. Then there was a 1921 Act. So it's only about 80, 90 years. But over those 80 or 90 years, the amount of energy that's been transmitted by television, radio, computers, lights, AC circuits has shot up. And there's a lot of it there. So if you're efficient in your design and careful in your experiments, then you most certainly can collect this energy and do something with it. Ash was saying earlier that you might want to run a sensor at a distance, like have a smoke detector that you never need to replace the battery on. So bear in mind, that's what we're saying here. Anyway, I hope you found that useful and interesting, and thank you for watching.